All right, continuing on. We're talking about procedural abstraction again. So our function should be written in such a way that somebody can use it without ever seeing it. All they would have to know is how to call it. So all they should need is basically our declaration, which is what kind of value does it return, what are the list of parameters, and our comments that tell them what's going to happen. So, preconditions and postconditions, page 275. If we look at 5.8 again, we've got all of our functions prototypes, the declarations, with comments that tell us what they're doing. And that's pretty good. Reads two integers from the keyboard, interchanges the value of variable 1, variable 2. What would be even nicer is if we could write that in terms of preconditions and postconditions. So the precondition would be, for swap values, for example, variable 1 and variable 2 have been given values. So our two arguments have values in them already because we're wanting to swap the values, right? And our postcondition would be the values that were in variable 1 and variable 2 have been interchanged. The first one is in the second, and the second one is now in the first. And so they've got another project that they go into here, the supermarket pricing project, which is going to divide the problem up into input, computing a new retail price, and outputting the results. And if you read the problem definition on page 277, they're basically trying to find out, or they're setting a markup scheme for their products. If you are going to sell a product quickly, and they define quickly as 1 day, 1 week or less, they only have to market the product up 5% to make a profit on it. If it's going to take longer than 7 days to sell, they want to mark it up 10%. Now, I would say this is a classic example of something that we need to make flexible so that if we figure out that it's not really working for us, we can change these values. The low markup percentage, the high markup percentage, and the threshold, how many days it's going to take to recoup our investment and so forth. So by using named declared constants, we can easily change those right up top if we ever need to. And they've written all of the comments in terms of preconditions and postconditions. Introduction doesn't take any arguments. There's no precondition. Basically, all it has is a postcondition. It's going to write some information to the screen. Get input as a precondition. We've prepared our user, or our user should be ready at this point to enter values. The postcondition, our two arguments are going to have the values that were entered by the user for wholesale cost and the number of days of turnover we expect. Price is written slightly differently because its precondition is what we were expecting. We have cost and turnover already filled in for us. But instead of a postcondition, it has a return. It's going to actually return a value. So think about precondition, postcondition, and return when you're writing your functions from now on, so that you can use those terms in your comments. So here's the program as written. Get input is going to prompt and get data for the pricing scheme. Price is going to calculate a new retail price from the wholesale price and the expected turnover. So that's this. And give output is going to take the wholesale cost, shelf time, and retail price and output those values. One more thing about defining functions. We can't nest definitions. You can't put the definition of a function inside another function. They have to be separated so that if I call one function from another function, we're not confused about where that function is. One thing we say about testing our programs is we should always test all kinds of input, which kind of begs the question, what constitutes a different kind of input? And so one of the answers to that would be something called a boundary value. So what do you suppose a boundary value would be in terms of this supermarket pricing program? Mr. Brantley?
As far as, would it be the threshold of 7?
The 7 days, all right. So we expect something to change around the 7-day mark. So it would make sense to test with values that are close to that boundary. 6, 7, 8. Those would be useful boundaries or values to test with. Other useful boundaries might be 1, 0, negative numbers if those are possible. Or if those aren't possible, make sure that we've prevented our user from entering them, stuff like that. In your your function declarations from now on. Now we have a whole section on testing and debugging functions. So we said we could test them with all kinds of of input data. But in order to facilitate that, without getting confused about what's happening, it might be handy to separate the pieces of our program and develop them separately until we're ready to combine them all together. So that brings us to the topic of stubs and drivers. Now, a driver program is a program that's written for the express purpose of testing a function to make sure it works properly. So just get input function. Basically, all it does is get input all day long and tell us what it got. Call get input, and then display the values that got set by get input, and then go back for another test. That's a driver. A stub would be a substitute function that we put in a program to take the place of a function that hasn't been written yet. 5.11 is a demonstration of stub. So here in the price function, you'll see the comment, this is only a stub. Basically, it ignores the input values, the parameters that it got when it was called, and just returns a value, a single value that's always going to be the same. It's a stub. It's not really doing anything. It's just holding the place for the price function that we haven't finished developing yet. So ideally, what they would like you to do is write your program and put stubs in for all the functions that you haven't developed yet, and then have a driver program that you test each of your functions in before you put it into your main program. That way, each piece of your program can be tested independently of all the other pieces. All right. Mr. Gear, page 286. Number 18, what's a driver program?
It's a function that actually does calculation. Temporary tool can be quite minimal.
Okay. It's a program whose whole purpose is to test a function that you're writing, to make sure that your function does what it's supposed to. All right. And Ms. Hargrove, what is a stub?
It is a stand-in value that tests, that you put in to test it for a portion of the code that we have not finished.
Okay. But it's for a function.
For a function, yes.
Okay. So a function that you haven't written yet, you have substituted a stub. It's it has the same declaration, the same header as your function that you're going to write, but it just returns a dummy value that you can use to test the rest of your program. All right, so Mr. Nelson, they want you to write a stub for this function in number 22, the rain prob function. So how would you write that stub? They've given you the precondition and the return. No idea? Mr. Rahim, any idea? Part of it they've given to us, right? What part have they given to us?
The rain underscore model.
So that's the declaration. The definition is going to start with that as its header line, isn't it? We can just type that in exactly the way it's written in the book. Now for the stub part, what do we do? This is just a stub function. What do we put here in the body? What is the function supposed to do?
Give the pressure and biometric.
The pressure is part of the precondition. Pressure is the barometric pressure in inches of mercury. Humidity is the relative humidity as a percent. And temp is the temperature in degrees Fahrenheit. Those are all parts of the precondition. What is the precondition means that happens before you call me, right? In a stub, we don't care about the precondition. We're just going to generate a value that fits, that will allow us to test the rest of the program. Ms. Hernandez, do you have any idea what we need to do to make this a stub?
Return point 2.
Return. Mr. Gear says return point 2. Just because some compilers are picky, I'm going to say 0.2. What would that mean?
20% chance of rain.
That would mean there's a 20% chance of rain. Well, Is that the real probability of rain? No, probably not. Only by chance would that be the real probability of rain. But it's a value that fits the return that we're told returns the probability of rain, which is a number between 0 and 1. 0 means no chance. 1 means 100%. So 0.2 would be 20% chance of rain.
So you just choose any number to use?
We just picked a number. It could have been 20%, 50%. As long as it's between 0 and 1, it fits the criteria of a return from that function, so it should work for the purposes of testing our program as a stub. That's all it has to do, is return something that makes sense within the bounds of our function.
So when is this practice? Why would
Well,
create it?
if you are creating a very complex program with a number of complicated functions in it, and you write them all at once in your program, and you start testing it, and it's putting out screwy results, how are you going to know where to start? So if we break it down into individual pieces and we test each piece separately, we know what this one's supposed to do. In this case, we just are testing the main program, and we want something that's going to supply us a value so that we know that our main program is displaying everything it's supposed to display, for example. So
I forgot. This section is debugging, and that's what we use.
yeah, that's the only purpose for stubs and drivers is for debugging. All right, so let's go on to general techniques, the first of which is keep an open mind. So I have had a student come to me and say, well, I can't get my program to compile. There must be a bug in the compiler because it's not working. Most likely, any problems you encounter will be your own fault. I, once upon a time, found a problem with a compiler. And this problem occurred whenever I was using as far back as this one was, I want to say whenever I was using more than a megabyte of memory, but I'm not positive. There was some magic amount of memory that the compiler was not smart enough to allocate that much memory. And so when we started using more than that amount of memory, stuff got overwritten. But I do not expect you as a beginning C++ programmer to find a problem with the compiler. So, first of all, you can assume you're doing something wrong. And it's going to make sense for you to systematically look through your code to see where you're doing something wrong. So dividing it up, if you didn't start off this way, dividing it up into the functions and drivers for each one, and the main program with stubs in it would be a good way to look at that. If you have someone who is a programmer, or if you want to get together with someone in class to look at each other's code, that's acceptable, as long as I don't see two pieces of code that are identical. Okay, your code should not look like the next person's code, and looking at each other's code doesn't mean here's my code, you can use it too. It means here's the way I did it, tell me what I'm doing wrong. Okay, here's the way I did it, tell me what I'm doing wrong. Then there are some common errors that you can check. And there are 5 that they have listed here. Uninitialized variable. So if you don't start off by giving a variable a value, it's going to have garbage in it. I guarantee you it's going to have garbage in it. And if you try to use that garbage, you're going to get some screwy looking results. Off by 1 errors we talked about before. If your code repeats 10 times when it should be repeating 11 times, that's an off by 1 error. Exceeding a data boundary, we haven't really talked about yet. We'll get more into that when we talk about arrays. Automatic type conversion. So if you put an integer in a place where a Boolean is expected, it's going to convert it to a Boolean. If you put a Boolean in where it's expecting an integer, it's going to convert it to an integer. And if you put a complex expression in there, you could potentially be converting back and forth multiple times. And a very common one that I see quite frequently is the equal sign, which means, anybody? Assignment, versus the double equal, which means
This should equal this.
compares equal to. So if you use a double equal, that's going to generate a Boolean because it's comparing the 2 things on each side of it and telling you whether they're equal or not. If you use a single equal, it's going to be assigning the value from the right side to the left side. It still can be used as a Boolean because the result of that calculation can then get converted to a Boolean value. So if I assign a 0 to a value in an assignment operation and then evaluate that as a Boolean operation, it's going to evaluate 0, which is false, which may not be what you intended. Next step is localizing the error. So they have an example here, display 5.12. 5.12 has an error in it. 5.13 is an attempt to localize that error by breaking down this complex expression into multiple simpler expressions and outputting the intermediate results. And by doing that, they were able to determine that they were doing an integer division by mistake. And then you can use the debugger, which I've already told you about, which allows us to step through our code 1 line at a time and examine the contents of variables and so forth. If you look under debug, you can see step into, step over. Step into allows you to test entering a function and stepping through that function code. You have to be careful with it, though, because it will also step through built-in functions that are part of the operating system that will show up as things that will look strange to you as beginning programmers. There's also the cassert macro, which basically allows us, or I'm sorry, the assert macro, which we can use by including the cassert library, but allows us to test a Boolean condition, and if that Boolean condition is false, will generate a runtime error for us. And we can turn that on and off by defining ndebug, which is a macro that the assert library uses to determine whether or not to actually compile into our code. So you could put assert macros at various places in your code. It's going to generate code that tests conditions, and then when you're sure that you've got your code completely debugged, you can define ndebug, and all of those, the next time you compile it after doing that, all of those asserts will no longer be compiled into your code. They won't cost you any code space, but you don't have to change or take out a bunch of print statements that were part of your debugging tools. All right, any questions about Chapter 5?
I have a question about something I ran into last night that has to do with debugging.
Okay.
It said I was missing the DLL for C++ debug. There's like CPP debug 120 DLL. And there was an error in my code since it couldn't call us the debug thing. I was having to go through every break,
Oh, yeah.
and there were a lot of breaks.
Well, for a specific error like that, I probably would have to look that up on the internet. I don't think I've encountered that specific one, but it sounds like some of the code didn't get installed properly in that environment. So I would search for that specific error message and see if you can find it. If you have trouble with that, send me an email and I'll see if I can help you with it.
It just said that DL is not good to do that. Unless the DL wasn't included in what Microsoft said.
Okay.
So I had to go in and install it after. Is that a common thing now? Since it no longer comes with it?
I haven't encountered that problem. Now, I installed the Visual Studio 2012, which is what we're using in class. And you installed
12.13.
Okay. So if it came from DreamSpark, I would expect it to all be in there. So I don't know why it wouldn't have installed.
I mean, I just went in and mainly installed the DLs that mess with it.
Yeah.
What was causing the error message was annoying because every time I tried to run the program, there were like 30 breaks.
Yeah.
And I had to skip through each one.
Well, and another thing you can do is obviously turn the brakes on and off. So if you've got a bunch of brakes that come before the problem you're having, you can just turn those off unless you need them for whatever you're doing at that moment. But so you were trying to do a step and it wouldn't let you?
Yeah, like I would go to compile and then it would just error out, but then it made me go through all the breaks in the code. And so I'd have to sit there for a while clicking.
Okay. Well, yeah, if it's not compiling, that's another problem. So it's not going to do you any good to try and debug it if it's not compiling. So the debug is going to just run whatever your last code base was rather than your current. So you have to fix all of the compile errors before you can, before that debugging is going to be useful. So our assignment for next week is Project 4. That starts on page 299, the change maker. So here's the text of Project 4. Write a program that tells you what coins to give out for any amount of change from 1 cent to 99 cents. So, for example, 86 cents can be given as 3 quarters, 1 dime, and 1 penny. So we're using quarters, dimes, and pennies. And they tell you do not use nickel and half-dollar coins. They have given you the declaration for the compute coins function that they want you to write and use in your program. So it's not going to return anything. It's going to have 3 parameters. A value parameter, coin value, that's an integer. A reference parameter, num, also an integer. And a reference parameter, amount left, that's also an integer. Before you call compute coins, the number, the argument for coin value needs to be set to a number between 0 and 100. And amount left should be between 0 and 100. So coin value is going to be what? An integer corresponding to what in our problem definition?
Coin value.
Coin value meaning
In coin value.
coin value. So what does that correspond to in our problem definition?
Oh, 86 cents.
86 cents is the total amount. Coin value is going to be the value of a particular coin we're looking at. So for a quarter, that would be 25. And for a dime, it would be 10. Amount left is going to start off with the amount that we're converting into coins. Okay? So if we read post condition, num has been set equal to the maximum number of coins of denomination coin value cents. In other words, quarters, for quarters, coin value would be 25. And num is going to be however many times 25 goes into 86 or whatever we're using. And amount left has been decreased by the value of the coins. Or you can think of it as the remaining value after we convert it into quarters, right? Here's their hint. Use integer division and the modulus operator to implement this function. So here we are calling compute coins with 25 for quarters. What did I say about numbers? If I'm calling compute coins, should I be using a literal value? What should I be using? Sorry?
Constant.
A constant. Okay. So I should probably declare a constant and call it quarter and set its value to 25 and put it there. All right. Here's my instructions. Should be easy to expand this to larger amounts. So let's pretend our program is what makes change whenever inside a vending machine and somebody puts a $5 bill in, well, that generates an input amount of 500. And we sell somebody a 75-cent item, so we subtract 75 from 500, get 425. I should be able to generate some number of coins and tell the coin dispenser to dispense this many of each of those coins. That's basically what we're doing here. Here's a grading criterion. You need to define compute coins as instructed and use it. You need to compute and report the correct number of quarters, dimes, and pennies. And repeat for multiple values. Use global constants for coin amounts. Verify that a valid amount has been entered. And I want you to call a compute coin the minimum number of times needed. I don't want you to be inefficient.
To get the value of the change, like for the vending machine example, you said, you do something that costs $5, you put in $5 for something that costs 75 cents.
Yes?
It's just going to be C and then the value of the change, right?
Yeah, your input, I'm not expecting you to write the whole, change it into a vending machine program. So this would be,
The input.
the input would be, here's the amount of change you have to give, and how would you give it. So,
But you want us to be able to go up to, instead of 86 cents in between 1 and 100, you want to go up to 5,000.
well, technically you'll meet the terms of the problem if you do between 0 and 100.
Right.
I'm saying if you want to make it do larger amounts, you can. But if you're validating if you're evaluating this value here,
Mm-hmm.
then make sure you tell me how you're validating it.
Okay.
So, for example, in a vending machine, it's probably only going to take nickels, dimes, quarters, dollars, and possibly $5 bills. So if we started with more than 500, that would be out of bounds. And you would not accept that as an input value. $5 would be 500.
So you want us to pick them up, basically.
So if you want to,
Amount.
if you want to choose 99 as your maximum, that's fine. Just make sure you say, here are the limits that I'm putting in my code. Okay? So I'm just going to, first of all, copy this declaration. It's already written for us. We might as well use it. And let's say change-making program, assignment 5, right? Is that right? And that's all garbage. So here's my coins function. And I'm going to have to define that. Now, if we were following the rules, I could just make this a stub, right? So to make this a stub, how would I do that?
Base value.
Sorry?
They just put in a value that would be easy to calculate.
Okay,
25 cents. 25.
25. What am I doing with 25?
I guess it doesn't have much else, so.
It's got 40.
Yeah, I got quarters. I'm going to take the whole one with that. So.
What does a stub function do?
Substitutes the value for a function that is not in
Okay, and so how am I going to do that in this case?
return only amount.
All right, this is a void function, which means
Doesn't have a
we're not actually returning a value. So what does happen? What's in our post condition?
It's going to change number and amount left.
Num and amount left, right?
Yeah.
So what do you want to change num to?
Does num correspond with the number of coins?
The number of coins, right?
So it depends. I mean, it's going to be a 4 or 5 or 3 or however many coins.
Right, except this is a stub. We're just
Right,
giving
so
it a value.
it's 5.
So in our example, we said 86 cents was going to be 3 quarters, 1 dime, and 1 penny. I'm just going to say 3. And amount left, you said we needed to set to something. If we were doing 86 cents and we
16 cents. So
That-
16.
well, 75 would leave 11, right? Now, those are only actually going to be the correct values for one specific case. But this is a step function. We don't really care. We're not trying to make it give us the correct answer yet because we just want our program to be able to compile first of all. All right, what else do we need in this program?
3 integers.
3 integers. What 3 integers do we need?
Value. So value.
Tell you what, before we start writing a bunch of code, let's write some pseudocode. I'm just going to write some pseudocode in comments here. How is this going to go in general? Now, our last problem that we solved, we said we were going to count from 99. We were going to count the bottles of beer on the wall and output something. So we would start with, we would count down from 99 to 0, and then for each number we would output some number of lines. How would we write the pseudocode for this program?
We return 3 coin values, so we need an integer for each one of those coin values.
Okay, but that's not pseudocode. You're
Enter, get a value from the user.
get a value from the user. Okay. So what kind of a value are we getting? An amount of change, right? All right. What's the next thing we need to do?
We calculate the highest, which would be the quarter amount.
Calculate how many quarters we can give in change. Next,
20 times, going with them out loud.
calculate how many times we can give for the amount left. And finally,
How many things?
all right? And then what happens next?
Output the amount.
Okay, output the results. And if we're going to do this in a user loop, we just say start loop here. Ask user if we should loop again. And in loop here. All right, so it looks like it can help me determine what kinds of variables I need. So a value from the user or change amount. And then we're going to be calculating how many quarters we'll have left and how many dimes we'll have left, how many pennies we'll have left, right? And I'm going to skip the loop part for a second. But let's say we're inside the loop here, so I get my indentation. Get a value from the user for the amount of change needed. Some of the examples that we've seen in this chapter, yeah, let's call a function to do that. And you're free to do that with a function if you want to. Or if you think that's over-engineering the problem, you can just do it here. Yeah, it's got that little red squiggly line under it, which means
You can put it in your input.
I can either do this, or I could say at this point it's up to you.
Any reason why you would do one of them?
If you were using a different namespace to have the whole.
If you're using a lot of namespaces and you needed to divide them up, or if you sometimes there will be a object or a variable with the same name in two different namespaces, and in that case you have to specify it like this. Some people just do it this way all the time because they want to explicitly let everybody know what's happening. I'm using cout that's in the std namespace.
Is there a list of the like namespaces and what's in what and what does what?
You can probably find some of that stuff on the internet or on the Microsoft Developer Network. Not in the book, no. Same thing for CN. All right, so I got the amount of change. Now, before I do the next thing, I'm going to do a little trick. I want to be able to tell the user how much change he asked for when I get done. And I know that the amount left is going to get changed by the compute coins function. So I'm going to copy it into a new variable before I use it. All right? Now I can call my function, right? How do I call my function?
Would
Sorry.
you store it for dimes also, or just for pennies?
Well, since the amount is in pennies, I'm just using pennies because I'm planning to pass pennies as the third argument, the one that's going to be changed to the amount left.
Mm-hmm.
Which means after I call it for dimes, it will be the number of pennies that are left after I've taken out quarters and dimes, right?
Mm-hmm.
So that has the added value of ending up with the right value for what I want it for. So I need to calculate how many quarters we can give and change. How do I do that?
The functions.
All right, the compute coins function, right? So how do I call a compute coins to make it do that? Mr. Nelson.
With, 3 divided by 25. So you know,
Well, what actually happens is going to happen in compute coins. Okay? Compute coins is the function I need to call to calculate how many quarters are in my change amount. So I'm going to call compute coins to do that.
it's not computed coins.
Compute coins. We're trying to figure out how many quarters. Mr. Rahim, what comes next?
Would it be the parentheses in the INT coin value?
All right, except INT coin value is the declaration for the function. That would be the parameter. What we need here is the argument. So what argument do we need for coin value? For quarters, specifically. So if we look at the problem definition, it said to use 25. I said don't use 25. What did I say to use instead?
Quarters.
All right. Quarter meaning
25.
25, but what are we talking about? A declared named constant for the quarter value. So how would I declare a constant to use for quarters?
C-O-N-S-T INT quarter equals 25?
Does that make sense? And while I'm here, I might as well do one for dime too. Right? So what do I put here?
CONST.
No, the constant is when we're declaring the constant. Here we just put the name of the constant that we're going to use. So what comes next, Ms. Hernandez? Number meaning what? What are we doing here? Let's look at our pseudocode. Calculate how many quarters we can give in change. So the compute coin function takes a coin value, a number, and an amount left. Coin value we already said was quarter, which is a constant 25. That's 25 cents a quarter. And what we're trying to get back is the number of that size coin. So what goes there? What are we trying to get back? What are we trying to get in that spot? We're not trying to get 25. 25 is how many pennies are in a quarter.
There are total points.
Total coins of what kind?
It's changing out.
Okay, of quarters. So if we're telling it we're looking for quarters, this is going to be how many quarters are we getting. If we look at our definition, num has been set to the maximum number of the coins of denomination coin value cents that can be obtained from amount left. So we take amount left, we figure out how many 25s will go into it, and we return that number here. So that's going to be how many quarters we can get out of our amount of change. And amount left is going to be that's pennies that we just told it we were going to be calculating from. So let's say I input 86, I store 86 in pennies, we call compute coins with 25, a place to put quarters, and our number of pennies, which was 86. We figure out in compute coins how many times 25 will go in 86, and we return that value here. Does that make sense to everybody? So how are we going to do that? Basically, dimes, we're doing the same things, right? So what is the same thing for dimes? Compute coins. Dime. Dimes. Pennies. So after we called compute coin with quarters, quarters had 3 in it. We started with 86. Quarters had 3 in it, pennies had 11. Now we call compute coins for dimes. Dimes now has 1, and pennies has 1. Do we need to call compute coins again? No, because we already know how many pennies are left. There's nothing to divide by. So Now all we have to do is output the results and see if we need to loop again. All right? And then all you have to do in compute coins is, instead of having a stub, put an actual function in here that does something. Using integer division and modulus. Does everybody think they know how to do that now? Who doesn't think they need to know how to do that yet? Everybody that has some idea how they're going to write compute coins, raise your hand. Okay. All right, well, as usual, if you get stumped or unsure how to proceed, contact me. I will try to get back to you as quickly as I can. And if you send me a message and you don't hear back something in, you know, half a day or so, try again, because I don't read all my email messages every day, so if yours doesn't stick out right away, I might not see it for a while. And if you want to be notified when there's a new video, either send me your email address that you want to be notified at, or you can put me in your circles on Google Plus if you're on Google Plus, and I will add you to the list.
You're going to continue putting shortcuts on the website, right?
Yes. Unfortunately, I didn't get that done very quickly this week, so it might, you know, it might be more timely if you got notified automatically. I'm just saying. Okay? Any questions?
Mine was over the email. Like the command screen.
Okay, we can talk about that individually.
Yeah.
Anything else? All right, we finished chapter 5, so quiz next week, and you have your assignment. I will see you then.
I looked at your email and I brought up my